Welcome to the Dickinson College Expert Show, where we connect you with scholars from Dickinson College. I'm Craig Lane. Thanks so much for joining us. I'm here today with Professor Ben Edwards, Professor of Geosciences and the Moraine Chair in Arctic Studies. His expertise is in the interaction between volcanoes and glaciers, Arctic and Alpine climate change, and the impact of volcanic ash on plants. And interestingly, you've traveled incredibly extensively with students, and we're going to talk about Iceland. Thank you for
One
being
of my
here.
favorite places.
One of your favorite places. How many times have you been?
I think close to 20.
Wow.
Something like that. Yeah.
Why is Iceland one of your favorite places?
I think it's about the landscape. I grew up out west. I grew up in Wyoming, which is wide open spaces and not many trees, at least till you get up in the mountains. And Iceland is wide open spaces with not many trees. Even when you get in the mountains, there aren't many trees. So I think that open landscape feels very familiar. I mean, obviously, I love the volcanoes, and I have been. First trip I did there was actually 1995 when I was working on my PhD project in Canada, looking at volcanoes in Canada, and they were similar to some volcanoes in Iceland that had more work. So my PhD supervisor decided it was worth a trip for me to kind of go see a place that would help me maybe figure out my place back in British Columbia.
Wow. Okay. So lava and ice, you have a lot of that in Iceland. That's your Twitter handle, right? Is lava_ice?
Yes.
Okay. So why is that important, and how is that relevant to Iceland?
Yeah. So the first volcano I ever worked on, actual volcano, was the start of my PhD, and it was covered by ice, and it was in British Columbia. And so I worked on that for 2 years and was having lots of questions. So we decided to go to a place where there'd been more work, and probably because Iceland sits, literally partly in North America and partly in Europe, they're just people from both places have gone there and done a lot of work. And it's pretty easy to access compared to some other remote places. Iceland has both volcanoes and glaciers for two slightly different reasons. So Iceland literally sits at the edge of the North American plate and the Eurasian plate, and those plates are pulling apart. And we're seeing the impact of that now almost monthly with these eruptions in Iceland. That's due to the fact that the plates are spreading apart, and as the plates slowly pull apart, they crack, and that allows hot rock to move towards the surface, and it melts, and then it comes to the surface and forms lava flows. So Iceland is an island partly because of that, but also partly because Iceland has got a second source of lava, or we call it magma when it's down inside the earth. There's actually two things that are producing magma that eventually comes up as volcanoes in Iceland. One is the plate boundary, but the other is Iceland actually sits on top of what we call a hotspot. So a hotspot literally is a place on the earth that is hotter than other places. And we think that the reason hotspots exist is that deeper in the earth's mantle, there are relatively hotter areas of the mantle that come up as plumes and hit the tectonic plates, which are at the outer edge of the planet. And where they hit those plates, the analogy we use is sort of like when, for anyone that's ever used a cutting torch to cut metal or to weld things, you've got a flame, and when you pass the metal over the flame's hot enough that it essentially melts and cuts through the metal. And so essentially this is what's happening at hotspots on the earth as well. There are a lot, maybe 40 hotspots around the globe. Yellowstone supervolcano is one of the more famous hotspots. That's where there's the North American plate in the west, part of the US, is moving over a hotspot, and it's burning through the crust and producing volcanoes every once in a while. Hawaii is a hotspot. Most of our volcanoes on Earth occur at the edges of tectonic plates, like Iceland. But these hotspots are connected, but not quite as directly to what happens with plates. And so hotspots can come up even in the middle of plates. And that's why we have Yellowstone not right at the edge of North America. That's why Hawaii is in the middle of the Pacific Ocean. Iceland is a unique example because you do have a plate boundary that's pulling apart, but it also, as it's pulling apart and the plates are moving apart from each other, they're moving over a hotspot. And so the hotspot is what produces that kind of extra kick of lava and volcanoes that actually makes Iceland an island. Because Iceland if it wasn't for the hot spot, probably would just be ocean floor. There'd be no island there. If you go to the north and south of Iceland, you're still at those plate boundaries, and there's still volcanoes that erupt, but they don't erupt enough to actually make an island. So it's a combination of those two different sources of magma, most likely, that actually makes Iceland a place that we can fly to and not go sit in a boat, but actually land on the ground. And because it's at a relatively high latitude, just under 66 degrees north, just outside the Arctic Circle for the most part, when you're in the interior part of Iceland, that extra elevation from the mountains means that it's cold enough during the year that you can accumulate snow over time, and that turns into ice, and that makes the glaciers. And that's why almost all the glaciers in Iceland are sitting on high topography, which is the volcanoes.
Wow. Okay. So this is like a gem for geoscience. This is really exactly in your wheelhouse.
Yes. And so there's lots of, it's really a mecca for geoscientists. There's lots of groups in the U.S. that go every year. There's so many people that are coming to Iceland who are interested in the geography and as importantly, probably the geology. One of the few places where you can see active volcanoes and glaciers sometimes at the same time, because sometimes there are eruptions underneath the ice, like the 2010 eruption that made a lot of news. And other times, maybe you'd be at the lava flow in the morning, and then by noon you can be at a glacier because they're that close.
So do you see this as a good thing for maybe science writ large or people's understanding of science because they can get so up close? I mean, Iceland is listed among the top tourist destinations pretty much annually at this point. People love to go there. The airline industry has spent a lot of money on building up their infrastructure there. So if you're going to Europe, why not stop in Iceland? I've heard that pitch before. Is that good for your field?
It's good in general, I think, for Iceland. It's given them a kick to their economy. For my field, a little bit of a mixed bag, quite honestly.
Okay.
There are hotels in places that didn't used to be hotels, so that's nice. But it's a lot harder to check into the hotels because there's so many people. And it turns out that for some of the work I do, I'm literally 5 kilometers from where these new eruptions are happening. And it may well be, if the sequence of eruptions continues for the next few decades, there may actually be eruptions in some of the places that I've been working with students the last 15 or 20 years. It's good mostly for the Icelanders. It has forced them to really change their infrastructure. Didn't used to be parking lots. You didn't have to pay for the parking lots. Also meant there were more public restrooms in a lot of places because it just wasn't a country that, was relying on a third of its income or more from tourism.
Wow. So this sounds like a really valuable place to be for you or to take students. What do you focus on when you take a group of Dickinson students to Iceland?
So it depends a little bit on the group. If it's a CASA trip, which is one of our departmental field trip funds, we mainly go to sites where we can talk about different types of rocks, different types of volcanoes, as well as glaciers. When we do alumni trips, we add a little bit more of the cultural history, a little bit more sort of modern cuisine type stuff. When we do some of the Arctic and Alpine research trips, those are focused on geology, but we're really trying to look at climate change at 3 different scales. So we can go to the old volcanoes, and some of them erupt when there's ice, some erupt when there's not ice. And we can look at the deposits, and we can actually figure out whether there was ice at a particular site when this volcano erupted. For a lot of those sites, there's no ice there today. So that's telling us about some things that have changed sort of on the time scale of thousands of years.
So that's fascinating to me because you wouldn't think like, oh, geology, you're just looking at rocks. You wouldn't think necessarily this is all tied into climate change. So, but there's clear connections there. And that's something that, like you said, you can explore looking at these different time horizons. What are the frontiers here? What are the things that you want to get into?
So I was just out in Chile a month ago with 3 students. So in Chile, we're working on volcanoes that also have either been covered by glaciers in the past or are covered by glaciers now. And we're trying to answer the question, does the volcano know when glaciers go really quickly? So there was a big body of ice called the Patagonia ice sheet that went from about central, not quite central Chile, but certainly the top of the southern third of Chile, all the way down to Patagonia, one continuous ice field. Now that's much smaller, and most of the Patagonia ice field is now in the southern part of that third of Chile. But there's still lots of volcanoes that have glaciers. And so when the ice melted relatively quickly, it changed the pressure that the volcanoes were feeling. And the question we're asking is, did it impact the eruption history of the volcanoes? So did it make the volcanoes erupt more or less? Is there any change at all that we can detect?
We have an Arctic Studies program that's very unique. You're the chair of it. This is something that going forward, it sounds like there is just more and more work to be done there. What are your hopes for students who come to Dickinson and get involved in this Arctic Studies program?
It's always great to have children, academic children, real children, following your footsteps to some degree. It's not too closely. You want to take the good steps, not the bad steps, right? And so we certainly produced that. A couple of our early students that went on programs, one of them's already a professor at a university, and he went on to do a master's degree and a PhD in the Arctic, and still works there quite a bit. I would say the program as it's developing, and Kristen Strock in Environmental Sciences and I are the two that are managing most of the research part of the program. The program that we're developing is much broader than that. So most of the trips we take will be designed to be research trips specifically to teach students how to collect data relative to monitoring global warming and climate change in the Arctic. And that'll be the purpose of most of the research trips. But there's a place in this for any student, any major, right? We have in the Trout Gallery, we have art that's come from the north that's been donated by our alums or sometimes by northern artists. We have people who work in our art department. Professor Servinas actually is going to be in Svalbard also this summer when I'm there. He's been there on a fellowship doing art, and that's about 78 degrees north, so it's pretty high north. But the Arctic really touches everything. Obviously, with what's going on in places like Ukraine, it touches geopolitics. The Arctic Council is the governing body for the Arctic. It's not part of the UN. It's put together just by the Arctic nations. And right now it's having troubles because Russia is by far the largest Arctic nation. And so they're trying to negotiate what they do with Russia when it's not behaving very well in places like Ukraine. So there's all kinds of geopolitics. As the sea ice goes away, there's going to be lots more transportation of goods. Even if we're not using resources in the Arctic, there certainly will be transportation of goods. It's by far the fastest way to get from the Pacific to the Atlantic. And you don't have to go through places like the Gulf of Aden, which right now is not a great place to take ships. So it's safer, it's also shorter, so it saves money. So that's all international business management, quantitative economics, data sciences. I would challenge someone to name a major that in 5 minutes or less I can't relate to our Arctic Studies program.
I want to bring this up too. Congratulations are in order to you because you have a Fullbright program fellowship coming up next year. Is that in Chile, correct? So is that an extension of the work that you're doing in Chile that you've done in the past, or is this something new that you're doing?
So kind of a combination. So the trips to Chile are part of a couple different programs, but the main thing that's taken us down there is a relatively big grant from National Science Foundation that's funded several universities and Dickinson to be doing this research on the Patagonia ice and the volcanic response. So my Fulbright will be to go spend a couple months in a town called Pucón, which sits on the flank of Villarrica volcano, which by two independent measures, a paper that I wrote with one of our alums and the Chilean Geological Survey, is rated as one of the most dangerous glacierized volcanoes on Earth. So a volcano that's got glaciers, we call it glacierized, not glaciated. Glaciated means it's been eroded by glaciers. Glacierized means it's still covered by glaciers. And so I'm going to go down and work with the Science Museum at one of the branches of the Universidad de la Frontera, which is based in Pucón. They have a science museum that talks about volcanoes. And I'm also going to hopefully do some work with some of the local guides to help give them some alternative places to go with people at times when they can't go to the top of the mountain because the government's saying the volcano is too active.
Well, we will be following your work intensely, Professor Ben Edwards. Thank you so much for being with us.
Good to be here, Craig.
And thank you for watching the Dickinson College Expert Show. I'm Craig Lane.